Hello and welcome to the section 2.4 lecture today. Today we're going to go ahead and look at operations with scientific notation. So we've dealt with exponents, we've dealt with scientific notation in the sense of really big numbers, also with really small numbers. And now we're going to look at adding, subtracting, multiplying, and dividing with scientific notation. It ought to be a good one. We're going to start off with a kind of pre-done example, and this deals with the populations of 3 countries: United States, Canada, and Mexico. So with these 3 countries, the thing that the book does is they turn everything into pseudo-scientific notation. It's kind of scientific notation. But they did it in a way that everything was to the same 10 to the 8th power. Okay, and that's one way that you can do it, and that's okay. I want to talk about how, we'll talk about the method 2 here in just a second. But so then once they have all those, they've added the 3 numbers that are before the times 10 to the power. They've just added these numbers, and they get 4.538. So then our final answer deals with that 4.538 times 10 to the 8th. See, the biggest issue here is that Canada's population is quite a bit smaller than the United States and Mexico at the time that all this was all this data was taken. So, it's kind of an issue with having one of them being to the 7th power and the other 2 being to the 8th powers. Probably the more common way that I see most students doing operations in scientific notation is to first translate everything into being standard notation. So you're expanding your scientific notation to give you whatever values they do. This is my 3.1 times 10 to the 8th. This one here is my 3.38 times 10 to the 7th, and this is my 1.1 times 10 to the 8th. So they just took those 3 values, put them into standard notation, and then they added them. Now, of course, this is going to give you bigger numbers, more digits to deal with when you're adding, but it's just addition. I think we can do it, okay? And so that's what they do here. It's not a bad way to go. I feel like I just kind of left that trailing. It's not a bad way to go. It's carrying more digits. It feels a little bit like doing a little bit more work, but you're safer, I feel, if you do it this way. Okay, so using the population table above, which is actually on the previous page, how many more people live in Mexico than in Canada? So Mexico was my 1.1 times 10 to the 8th, and Canada was my 3.38 times 10 to the 7th. So the easiest way to do this is to use that method 2. 1, 2, 3, 4, 5, 6, 7. So 1, 2, 3. 1, 2, 3, and there we go. That way will work almost all the time. Turn it into standard notation, and in this problem we're going to have to do something a little bit different, but we'll talk about that in a second. My 3.38 times 10 to the 7th is going to have, I'm going to write it this way because it's going to have 5 zeros. 3, 4, 5, 8, 3, 3. So for this problem, they want to know how many more people live in Mexico than Canada. That is a subtraction problem. Okay, and I'm going to do it this old school way of subtracting. Just stack my numbers up, subtract away, and they do want our answer in scientific notation, so I'll do that afterwards. I need this 0 to be a 10. I actually have to pull all the way from here. So that turns into 10, turns into 9. That's a 10, 2. 9 minus 3 is 6. can't go 0 minus 3, so turn that into a 10. 10 minus 3 is 7. And so getting my digits all in line here, the standard notation answer is 76,200,000. Now I want to turn that into scientific notation. I move my decimal back 3, 6, 7 times. So 7.6 times 10 to the 7th. The next thing we're going to look at is multiplying and dividing with scientific notation. This is where things, again, can get a little bit tricky, and there's probably a quicker way, and we're going to go ahead and, I'm sure, look at an example that way. There is a quick way to do it using properties of exponents and those kind of things, but in the end, that method 2 strategy, I've turned it into standard notation, do your operation, then back into scientific notation, is obviously more common from what I see. It says here, when the sun makes an orbit around the center of the Milky Way, it travels a whole bunch of kilometers. The orbit takes 255 million years. Sorry, 225 million years. At what rate does the sun travel? So this is kind of a science equation problem using, the base formula is distance equals rate times time. Okay, and they've altered that formula just a little bit to solve it for rate that equals distance over time. So when you're talking about how fast something goes, miles per hour, kilometers per hour, those, meters per second, those are all a distance divided by a time. Okay, and that's what we're trying to find here. So they use the scientific notation strategy. Okay, they have the 2.025 times 10 to the 14 kilometers. That's how far the sun travels. And then my 225 million years. They wrote that out. And then what they do is they write that into scientific notation as 2.25 times 10 to the 8th. Okay? And now they're going to do the operations using scientific notation and the properties of exponents. Okay? So in order to do that, in order to make this work, we do get one thing that's really nice here, and it's almost the best way to describe it is that we can split this problem into two different division problems. One being the numbers out in front, and the other one being the powers of 10. Okay? So they do the 2.025 divided by 2.25 and get 0.9. Okay, then they use properties of exponents with this 10 to the 14 over 10 to the 8th. That's a subtraction property of exponents. Okay, to get 10 to the 6th. Now the issue here is, with my 0.9 times 10 to the 6th, is this in scientific notation? It is not, because this number right here is not between 1 and 10. Okay? Realistically, this whole number right here, the 0.9, is not a number between 1 and 10. So you do have to adjust it. And same thing, there is a trick to do this, right? There is a trick to know that, you take 1 away from the exponent and you can move the decimal that way. I honestly do not recommend doing that. I would recommend taking this 0.9 times 10 to the 6th. I'm moving the decimal 6 times to the right, which is going to give me 5 zeros. 9, 1, 2, 3, 4, 5. And I get a comma right there. I recommend turning it into the standard notation and then going back into the scientific notation. If I think about moving that decimal back 3, 4, 5 times, it's going to be between the 9 and the 0 where I want it to be, making this number right here a number between 1 and 10. Okay? So if you're unsure about how they did this, the easiest way is turn this into standard notation and then back into scientific notation. Okay? And then they check their answer using multiplication, and for that they've expanded the numbers into their standard forms. So again, kind of using that idea that that we can, if we want to go standard form, we can go standard form. If we want to use, our scientific notation, we can do that as well. All right, so this one, it says light travels at a speed of 1.86 times 10 to the 5th miles per second. It takes light from the sun about 4.8 times 10 to the 3rd seconds to reach Saturn. And so we want to find the distance from the sun to Saturn. Write your answer in scientific notation. Again, we're looking at a distance equals rate times time problem. So that's abbreviated D equals RT. And we're actually looking for the time, right? We're going to find distance. Ooh, hey. Yeah, so we're looking for the distance. So I have a rate, miles per second, and I have a time that is seconds. So here what I'm looking at doing is going 1.86 times 10 to the 5th, and then multiplying that by, maybe we'll use parentheses here. That feels a little bit better. To use parentheses. And then we're multiplying that by 4.8 times 10 to the 3rd. For this one, I'll keep it in scientific notation and do the operation that way. Okay, for the next one, I'll do that other method of standard notation and then adjust it. Okay, so for this one, we get our get rid of that. 1.86 times 10. I'm going to use this to the 5th power. Nope, I don't want to do that. I don't know what I'm doing. Gosh. Somebody stop me. 1.86 times 4.8. That's what I was looking for. And we get 8.928. 8.928. Again, this is a number between 1 and 10, so we're good there. And then I'm going to deal with my exponents. I have 10 to the 5th times 10 to the 3rd. With the properties of exponents, that's a multiplication, and we add our exponents. So this is from 2.1. Okay, from like our first day in class. So that's going to be 10 to the 8th. And there we go. All right, let's do this next one in standard notation, and then we'll turn it into scientific notation. All right, it says light travels at a speed of that fast, miles per second. Sorry, per minute. Pluto's average distance from the sun is that many miles. On average, how long does it take sunlight to reach Pluto? So this is another distance equals rate times time, but we're trying to find the time this time. And when we're trying to find time, that formula looks like this. Distance over rate. And we have a distance right here, and we have a rate right here. I'm going to turn that 1.17 times 10 to the 7th into standard notation. So I'm going to have 5 zeros. 1, 2, 3, 1, 2, 3. There we go. All right, that's a little bit easier to deal with. And so for my equation here, my distance is 3, 6, 7, 0. Wow. Didn't know I could struggle that much writing a number. 3, 6, 7, 0, and then 6 zeros. 1, 2, 3, 1, 2, 3. And we're going to divide that by this number here, 11,700,000. 11,700,000. And I'm going to use a calculator for this. So we have 3.67 billion, right? Yeah. So we have 3 670,000,000 divided by 11,700,000 right there. And so I get 313.67. That is not in scientific notation, and honestly, you know, would we really need to turn it into scientific notation with this size of a number? Probably not, but we can do it anyways. So we're moving the decimal to the left, we get 3.1367. And that's going to be times 10 to the second power, because we moved it 2 times. Okay. All right, looking at scientific notation on a calculator, and this is a problem that we kind of talked about before. And based on the calculator that you have, it's either going to have a capital E. Typically, the display will have a capital E, and it'll actually, the calculator will probably have a button labeled EE most of the time. Most calculators have a button that's labeled EE. And as they say, that takes the place of times 10 to whatever power. Okay. Let's see. This table shows the approximate areas for 3 continents. All right. And they're just showing you how to do that work on a calculator, but they're also highlighting that calculator notation. Okay. So yeah, let's go ahead and look at the your turn problems for that. They just want us to enter this, to write this using that calculator notation. So anytime I see a times 10 to a power, that's going to be written with an E, capital E. And they kind of do it right here. A lot of times that E looks really small. I'll show you what I kind of mean by that. It'll look like 7.5, and then a lot of times that E, it's a capital E, but it's like a small caps E written down there. This one we're going to have 3E7, sorry, negative 7. Let me fix that. Let's see. Here we're going to have 2.7, capital E, 13. Notice that we're not writing these as like exponents, because that's what the problem actually does for us. And then these last 3, we're writing them into scientific notation. So this is going to be 4.5. We're just going to undo the process we just did by replacing the E with a times 10 to the power of whatever they give us. 6.98 times 10 to the negative 8. Okay. All right. Hopefully that helped out. You know, today was just a day to sort of incorporate everything that we've learned as far as scientific notation goes, as well as some operations that we can do with them, and a little bit of calculator work. Okay. Code word time. The code word for today's lesson is going to be notation. I'm feeling it right now. Feeling the notation changes. Okay, so notation will be your code word. Your code word is notation. Write it somewhere in there. Get that question right. Have a good day, and we will see you in class.